Back here in Canberra, of course, we were working very closely also not only with our antennas and our people here, but with our sister station over in Goldstone, California, with our team over in the United States. And we used a whole bunch of antennas to provide communications. So we were prime here in Canberra. We provided the key link through our 70-metre antenna, Deep Space Station 43. We had two other 34-metre dishes busy communicating, and we're also using some of the dishes in California. So NASA never leaves anything to chance. And you can see it was kind of a complicated night. You know, who was going to be talking to who, what, when, and where, and which antenna, and what period, and some really key moments. It wasn't just us sitting back here on Earth receiving the data from the spacecraft. We're also involved in a very important science experiment, the REX experiment. So this is a little simulation of the approach of the spacecraft towards the planet. The spacecraft changing its position, orienting itself, moving its cameras to take images of the planet and its moons, learning everything we can about it, racing towards the planet at 55,000 kilometres per hour, flying just 12,500 kilometres above the surface of Pluto, and then swinging off into deep space, leaving Pluto and its moons behind. And right at this moment, a signal is being received from the Canberra station, being beamed at high power straight at Pluto, but it left Earth 4.5 hours earlier. That's how long it takes for a radio signal travelling at the speed of light to get there. So that signal would pass through Pluto's atmosphere at the exact moment that the New Horizons spacecraft was passing behind the planet from Earth's point of view. So that signal would pass through the atmosphere and reach a credit card-sized instrument on the surface of the spacecraft, so that we could actually figure out the density and layering of Pluto's atmosphere, and even some of the compositional data. Of course, we sent that signal from Canberra. We beamed it through Pluto's atmosphere, reached the spacecraft, and they were able to analyse those layering in the atmosphere. This is the surface of Pluto down here, and layering the atmosphere going up over 83 kilometres above the surface. So that atmosphere is primarily nitrogen. When we headed to Pluto, we actually didn't know where Pluto was. We knew it was there, we just know exactly where it was. You know, where is the planet in that fuzzy point of light? So since January this year, the spacecraft was taking a science campaign, an imaging campaign, so that we could actually, as we got closer, to actually see where Pluto is. From 20 million kilometres away, it was still a fuzzy blob off in the distance, but this was getting exciting for the science team, not so much for all of us. You know, you think, oh, do you think they could have set better cameras, you know? But, so a little bit closer, we started to get nice images of Pluto and Charon together, some interesting clues coming together. Some weird features started to appear on the surface, these polygonal type features appearing there. Pluto's rotation takes about 153 odd hours, so about 6 Earth days. So we're able to see right around it as we approached. And then we got what is now the classic view of Pluto, with this gorgeous heart-shaped feature on its surface, so Pluto was sending us its love. This is the shot I've been waiting for, I think, my whole life. This is the ultimate departure shot. The shot taken by New Horizons after it passed by Pluto. Pluto's now backlit by the sun. The rest of the solar system is behind that. That's just a beautiful thought. And we head off and leave the traditional solar system behind, at least.